Three,
Assalamu alaikum. My name is
two,
M.Shariq,
one.
and today the topic is fractals. A fractal is a never ending pattern. Fractals are infinitely complex patterns that are self similar across different scales. They are created by repeating a simple process over and over in an ongoing feedback loop. Driven by recursion, fractals are images of dynamic system. The pictures of chaos geometrically they exist in between are familiar dimensions. Fractal patterns are externally familiar since nature is full of fractals. For instance, trees, rivers, coastlines, mountains, clouds, sea shells, hurricanes, etc. Abstract fractals such as Mandelbrot set can be generated by a computer calculating a simple equation over and over. There are three types of fractals: natural fractal, geometrical fractals, algebraic fractal. Natural fractal. The spiral is another extremely common fractal in nature, found over a huge range of scales. Biological spirals are found in the plant and animal kingdoms, and non-living spirals are found in the turbulent swirling of floods and in the pattern of star formation in galaxies. All fractals are formed by simple repetition, and combining expansion and rotation is enough to generate the spiral. Fractals are found all over nature, spanning a huge range of scales. We find the same patterns again and again, from the tiny branching of our blood vessels and neurons to the branching of trees, lightning bolts, and river networks. Regardless of scale, these patterns are all formed by repeating a simple branching process. A fractal is a picture that tells the story of the process that created it. Purely geometric fractals can be made by repeating a simple process. Algebraic fractals. We can also create fractals by repeatedly calculating a simple equation over and over. Because the equation must be calculated thousands or millions of times, we need computers to explore them. Not coincidentally, the Mandelbrot set was discovered in 1980, shortly after the invention of the personal computer. Mathematical fractals are infinitely complex. This means we can zoom into them forever and more detail keep emerging. To describe the scale of fractals, we must use scientific notation: 1000, 10 to the 10 to the power 3 million, 10 to the power 6 billion, 10 to the power 9 trillion, 10 to the power 12 quadrillion, 10 to the power 15. Because of the limits of computer processors, all the full dome fractal zooms stop at a magnification of 10 to the power 16. Of course, the fractals keep going, but it becomes much slower to compute deeper than that. 10 to the power 6 or 10 quadrillion is incredibly deep. To put it in perspective, the diameter of an atom is about 10 to the power minus 10 meter. So as we zoom 6 orders of magnitude smaller, we are looking at things a million times smaller than an atom. Or to look at it another way, as we zoom into the fractals, the original object keeps growing. How big does it get when we have zoom in 10 to the power 16 times? The orbit of the dwarf planet Pluto is about 10 to the power 12 meters in diameter. If we start zooming in a 10-meter dome, then the original image grows to a size larger than our entire solar system, 1 lakh times larger. All of these zooms are just scratching the surface of the infinitely complex. Some fractals, like the Mandelbrot set, become even more intricate and beautiful the deeper we explore. The image above exists at a depth of 10 to the power 176 magnification. A commonly asked question is, What are fractals useful for? Nature has used fractal designs for at least hundreds of millions of years. Only recently have human engineers begun copying natural fractals for inspiration to build successful devices. Below are just like computer chip cooling circuit and cell phones and other devices, etc.